Assalamu alaikum everyone. In the last lecture we have covered a simply supported beam with the distributed load, and we have determined the stresses as well and the maximum deflection. Okay, this is basically the mechanics of material book. Okay, so we had used Q is equal to 5 Newton per millimeter. So this is the maximum deflection formula. So using this formula you can basically compare your results. So in today's lecture, what we are going to do, we will perform the analysis on the simply supported beam, but this time instead of the distributed load, we would select this point load, and you can compare your results with the maximum deflection here, and then you can also compare the stresses using the flexural equation. You can compare your results with the bending stresses results using the formulas available in the text. So just start here. So now this time go to the workbench and then select the static structural analysis. Rename it to as a point load. Okay, so in the geometry section, just double click here. Okay, these icons, you see that they have some meanings. Okay, for example, we know that engineering data, we have the structural steel is basically the defined material. So if you see that, it means refresh required, and it means unfulfilled, and it means upstream data does not exist. Okay, so because I haven't this data does not exist, I haven't set up the solution yet, I haven't defined the geometry, and now I need to focus on the geometry. And then these four or five you should keep it in mind. Okay, if you see this sign, it means update required. We will see that in the lecture today. So just double click that, because I've selected the design modeler as a default geometry editor. So when I click the geometry, so the design modeler will open. So you can see that here design modeler. So after a while you see that this is the design modeler interface, but this time, instead of creating the beam using the XY plane and then sketching it, I would go to the primitives. So I would just go to the create, and then from here primitives, I would create a box here. So you see that this is the point here, this is the coordinates of the point. So this is basically, you see that, so if I zoom in, okay, so it means okay, you see that this is 5 meters. So first I need to change the units. Okay, so just let me change the unit first. Okay, let me just delete it and then change the units to millimeters, and then go to the create again, and then primitives and the box. Okay, so you see that right now this is the box, and this is the point end point with the corner points 0.1 definition. So I can specify the coordinate. Right now it's 0 0 0, it means x value is 0, y value is 0, and the z value is 0. So that's fine. And then I need to define the values in the x, y, and z direction. Okay, for example, okay, I want to keep that in x and y direction of 40 mm. So just click there, 40, and the y is also 40, and the z direction, okay, I want to create it to be how much, 1000 mm again. So this is the same cross section or the same length I have defined before. You see that, and then click generate. So now I have again the beam, and again you see that this is one part, one geometry. So I have created this beam using the primitives. So now I have my geometry. I can just close it from here. So the next step is basically model. Okay, so if I just double click here, Ansys mechanical will open, and I will define my boundary conditions and the other specs. So I will use the same data, and before that it was P was 5 Newton per millimeter, if you remember. So right now I will apply the load of 5000 Newton, 5000 Newton. Okay, so for the point load, you look at that. I need a very small area. So how I can do that? Okay, because I need an edge there. Okay, so which is basically not defined here in the Ansys mechanical. So that's the main issue. So I have my you see that I have my geometry here, but if I select the force here, you know that I can specify my fixed point. Okay, so just let me select this edge. Okay, this edge, and then apply, and just click here, apply. Okay, the fixed point I have applied here, and on the other edge, okay, this just zoom in. Okay, using the right mouse button, select the edge. Okay, this one, right click, and then insert as a displacement. So I need to, for the x component, okay, I don't want the moment out of plane moment, so just 0. And the y moment upward direction, okay, this should also be 0. And the z, okay, along the axis, okay, it should be free, so that's fine. Okay, and then for the force, okay, you know that I need to for the force part, I need to apply the force on this at the center, but I don't see but Ansys don't find any edge here where I can apply the force. So first I need to create a line here. So let's see how I can do that. Okay, just let me close it from here, and then I will go to the design modeler again. Just double click here, and then you see that I need to split this face into two halves. So how I can do that basically? So just look at that. Okay, so to draw a sketch, I first need a plane. So let me draw a plane here. Just select this face, and then on this face I will define a new plane. Okay, just click here, this is the new plane, and then I have created this plane, and then generate. Okay, now I have this plane here, and in this plane I want to draw a line here. So let me just insert, and then sketch projection. Okay, so just select this face, right click, and then sketch projection. Okay, and then select this face and apply. Okay, now you see that what has happened. Right click and then generate. Now it has created the sketch. Okay, of this upper this was the face. It has created using the boundary, it has created a sketch. So this is a rectangle here. So I just projected this face into a new sketch, this one. So now I need to define a line here. So I can go to the sketching, and in the modify section there is this option, the offset. Okay, so you just select this offset, and I will offset this edge to the center, which is 500 mm. So for that, okay, just select the offset, and then select this edge, and then right click, and then select this option, end selection. So you have to define the end point. So I will just click here, and then now I need to define the distance here. So just go to the dimensions again, horizontal. Okay, I will define the horizontal dimension between these 2 points. So just select here, and then it's almost 500, so I can just specify the 500. So now you see that I have created a line which basically divides this upper face into two half section, but this doesn't split the face. I need to split the face. For that, what I will do that, where is this tool? In the tools option, there's this option, face split. So select this face split option, and first I have to select the target face which I want to split. So select this face and then apply. And in the tool geometry option, okay, I need to select that edge, okay, which basically divide this upper surface into two halves. So I would select this edge using the edge selector. Okay, just select the edge selector, this one, and then apply. Okay, and then you see that face split, and then click generate. Okay, now you see that now I have created two faces. Okay, I have split this upper face into two halves. So that's why, which is basically done. Okay, so just close here, and then again click model again. Yes, just update the data. Okay, so this is my model, and now I want to apply the force at right in the middle. So for that, what I need to do, using the edge selector, I would select this edge selector, select this edge, right click, insert, and then I would select the force. Where is the force? Okay, first select the static structure. Okay, then the edge, okay, which is basically this one, right click, insert, and then the force. And then now I would define the force. Okay, I would define the force this time using the components, because I have this x, y, and z. So in the y direction I would define the minus 5000, which is basically the total force. So you see that this force is applying on a very small area. So you might have seen there are some singularities here. So we would observe that as well, because there would be stress concentration in this area, because practically it's not possible that the force acts on this very small area, because normally the force is distributed. We will look at that, how we will create the patch here using the design modeler. So now the force is defined. So just create the mesh here. Again, let me define the size here, okay, which is basically, because it was 40 mm, so let me define it to 20 mm, and then right click, and then the generate mesh. Okay, so it will take a minute. Okay, so now I have very fine mesh. Okay, to check the quality of the mesh, you can just click here in the on the mesh tab and the metric, and you see that just select from here and then the element quality. So right now you see that this is basically brick elements. So since you see that here it's 1, so it means this is the perfect element. Okay, so this value should be 1. Okay, so which is exactly, so it means this is the perfect mesh for this geometry. And now I want the data. Let's say that I want to determine the directional deformation again in the y-axis, because I'm interested in the y-axis. Right click, and then the von Mises stresses. Where are the von Mises stresses? Equivalent von Mises stresses, and then right click, and then solve. Okay, so you see that this is the deformation. Okay, direction deformation is y direction, which is 2.45 is the maximum deflection here at the center. Okay, you can just click here. Sorry, it's minus 0.27. Okay, it's taking that, but positive and negative difference. But you see that the maximum deflection is here, minus 2.45, and then the equivalent elastic strain. Okay, I didn't want to calculate that, but just say that okay, the maximum strain occurs here. So I wanted to calculate the stress. So just right click, stress, and the equivalent von Mises stress. Results, evaluate all results, and then you see that okay, this is the results. Okay, the stresses are 115 megapascal. Okay, the maximum stress occurs here. Previously it was 58 megapascal when the force was distributed, but now you see that these stresses are much higher before. Again, the stresses on the neutral axis are very small, and then this is the maximum deflection in the y direction. Okay, you can compare these results using this option. Okay, another thing I want to show you. Okay, let's say that let me for the equivalent stress. Okay, so you see that. Okay, so if just let me play the animation here. So the force varies from 0 to, you see that 0 to 5000 Newton. Okay, and then I can 0 means time 0 means the force is 0, and 1 means the maximum force applies. So I can just stop here at any moment, and then now this is basically the 0.73 times multiplied by how much force was that? It was 5000. Okay, for that it's